Bismillahirrahmanirrahim and welcome to Rahman Digital Production. Today we are going to start exercise of chapter number 2 and this is lecture number 9. Before going into the detail of exercise, I request you people to please subscribe my channel and press the bell icon so that you will be immediately notified when I upload the new video. I don't want that you people should miss any lecture. This is lecture number 9 and let's directly jump into the exercise. But before that, let me tell you that exercises are designed to test your knowledge of that topic. In that topic, you have to master yourselves and then you will be able to understand the questions. If you are not feeling comfortable, don't jump into the world of exercises. Go back, revise the lectures, learn it. I given you the basic idea. If you want to go more in depth, then go to the net, find more information about the topic. Once you feel confident in the topic, then come and solve the question. If you can solve the exercises, it means that you can solve the CIE papers. For that, the basic knowledge is required. Okay, without wasting your time, let us start. The exercise 2 is given on page number 33. And the first question is saying the average speed of a car is 35 kilometer per hour. So we are representing speed with capital V and we are writing 35 kilometer per hour. This information is given to you. How far can it travel? So we have to find the D, yani distance. And then T is given as 45 minutes. T is given as 45 minutes. Now, many students are not paying attention to these information, and that is one is given in the hour and one is given in the minute. So the unit must be the same. Either you have to convert that h into the minute or these minutes into the hours. And you know, for converting the minutes into the hours, we have to divide it by 60. When we are dividing it by 60, we are getting 0.75. So we are getting 0.75 hours. Now both the units are the same, so you can give answer kilometer per hour. The four choices which are given here, you have to do what? You have to go according to those answer. All the answer are given in the kilometer. So if you want to cancel the hour, you have to convert it into the hour. You know, as we know, as we know that V is equal to, yani, speed is equal to distance divided by time. We have to find the distance here. So we have to make the d as a subject, and then we can write v multiplied by t. We have both the values, that is v is equal to 35 and t is equal to 0.75. So 35 multiplied by 0.75 is equal to 26, and that is kilometer, because you can see it is given in the kilometer. So we have to write 26.25 kilometer, and that is the answer, and the answer of this is C. So the answer in the four choices 26.25 is given as C. The number two question inside uh, uh, the exercise is saying a car accelerates uniformly from 5 meter per second to 13 meter per second. So we are saying that u is equal to, directly I am writing that delta V is equal to what? Because there is change in the velocity and we are having the final velocity as 13 and the initial velocity is 5. So it means 8 meter per second is the change in velocity. What is the acceleration? The time is given as 4 second. The time is given as 4.0 second. Now this is also second and this is also second, so there is no need to convert the units from one unit to another unit. And then we have to find acceleration. They want us that how much acceleration is there. You must understand, if there is a change in the velocity, then there will be acceleration. So we have to find the acceleration. Is acceleration, which is a vector quantity, is rate of change of velocity with respect to time. So we are having both of them, that is 8 meter per second and 4 second is the time for 1 zer and for 2 zer. So it means 2 meter per second square, and that is the D part. 2 meter per second means answer is D, and that is given to you in the four choices. So now we are turning our focus to question number 3, and that question is saying a ball which is thrown vertically upward at 1.2 meter per second decelerate uniformly at 10 meter per second square. Deceleration, negative acceleration and retardation is pointing to the same concept. It is doing what? It is the same concept, negative acceleration. So we have to denote this negative acceleration by minus. Remember these words. Let us write the data first. They given us in the question that there is change in the velocity delta v and 0 minus, because when the ball is thrown upward its initial velocity is 0, and there is it is reaching to the final velocity 1.2 meter per second, so it is minus 1.2 seconds, meter per second, meter per second. Now what other information we are having? The other information which we are having is a is equal to minus 10 meter per second. How long it will take? So a is equal to minus 10 meter per second square, and how long it will take means that what is the time. So ladies and gentlemen, let us solve this question remaining in the context of the data. As we know that acceleration is delta v divided by t. So because we are finding the time, so t is equal to delta v divided by a. We are having minus 1.2 divide by minus 10. This minus will be cancelled with this one, and if I calculate 1.2 divide by 10, so it is 0.12, 0.12 seconds. And ladies and gentlemen, that is the option number A. So answer is A. Answer is A. Now we are doing question number 4. They given us 4 different graphs. We talked about the velocity time graph in greater detail. First, they are telling us that this is A option, and then they given us the this one, and then in the C they given us this graph, and in the D they given us this graph. Now this is A and this is B, this is C and this is D. The question is saying which one of the following velocity time graph, because this is V and this is T. This is V, this is T. This is V, this is T. This is V and this is T. They are saying that which one of the following velocity time graph shows an object slowing down with non-uniform acceleration. We talked about this in the previous lecture in greater detail. This is decelerating. Yes, this is the answer, but it is uniformly decelerating. But the question is saying non-uniform deceleration. So this is not then the answer. Now the second one is increasing. This is not deceleration. This is also not deceleration. It is the velocity is increasing, but the acceleration is also in positive direction. Now this one is the answer because non-uniformly it is a curve and decreasing. So the answer is D part. Okay, ladies and gentlemen, that was the whole story about the section A. Now we will turn our focus to section number B. Okay, ladies and gentlemen, We are starting section B, and that is structure question, not MCQs. The first question, A part, is saying define average speed. We defined it completely. Again, I am refreshing your memory. Average speed is the total distance covered by a body in the total time. Total distances covered by a body divided by total interval of time is called average speed. When we are dealing with the variable speed, then we have to take advantage of the average speed, because variable speed cannot be explained in one term. Variable speed means that sometime the car or the object or the particle is moving with one speed, and at the other time either they are gaining the speed or slowing down. So we cannot say one value for the speed, then we are finding the average speed and we will say one value that this car was moving from Peshawar to Islamabad with this speed. So average speed means total distances covered by a body in total time. Now the second question, I took this book in my hand because I wanted to show you the figure. See this figure. If you are not understanding this figure, stop the video, understand it, and then come back to the solution. There is a figure given here. So now let us solve it. The figure below shows the route taken by a cyclist as he journeys past the places marked by A, B, C, and D before returning to A. Now the first part is saying calculate the average speed in kilometer per hour from A to B. Okay, we have to see that from A to B distance is 10 kilometer. It is given in the uh, this is one number question and B number part. From A to B, from A to B, distance is 10 uh, kilometer. Now the time taken is from 6 a.m. to 9 a.m. It is given in the book. So time means from 9 minus 6, it is equal to 3, and that is hours. Yes, from 6 a.m. the cyclist started its journey, and till 9 a.m. we have to find the what we have to find the average speed. So average speed is denoted by enclosing capital V inside the angles bracket. Okay, now average speed is equal to total distance, which is 10 kilometer, and divide by total time, which is 3 hour. So when we divide 10 by 3, then it is 3.33 kilometer per hour. 3.33 kilometer per hour, and that is the answer. Now we have to see from that was part number 1, and here we have to see part number B. From B to C, what will be the average speed? They given us the distance is equal to 8 kilometer, and again time from 9 to 12 noon is 12 minus 9, which is equal to 3 hours again. And again we have to find the average speed. So average speed is equal to 8 divided by 3. When we divide 8 by 3, we are getting 2.7. We are getting 2.7 kilometer per hour, because you can check that on the calculator. Now the third part is saying that there is a technical point in this. Please pay full attention. The total distance, they are saying to find the uh, speed over the whole journey. So total distance, total distances is equal to, first it is 10, then it is 8, then it is 7. 10 kilometer plus 8 kilometer, then 7 kilometer, and then we are having 12 kilometer plus 12 kilometer. When we calculate this, so it will come out to be 37. 37 kilometer is the total time taken by the cyclist. Now we have to find the total distances. That is a technical point. Total time. So total time taken is equal to 12.1 hours. 12.1 hours. That is the technical point. Why not 12? Because when we are starting from 6 a.m. until 6 p.m., then it means 1 minute is over. If it is 11.59, then it means that it is 12 hour. Before the 59 second, that is 12 hour, but if it is 60 second, then it means that 1 second is increased. So we are taking 12.5. So average speed overall is equal to 37 divided by 12.1, and that comes out to be, I calculated you in advance, so 3.1 kilometer per hour will be the average speed. You can cross check this by dividing 37 by 12.1, and that comes out to be 3.1 kilometer per hour. Now ladies and gentlemen, we are turning our focus to question number 3. Question number 3 has given us a graph in which there are three different lines they given us. One line is A and that is a straight line. The second line is B and that is a bit sloped line, that is B, and the third line they given us, that is C, which is this one. And remember that this graph is velocity time graph. Velocity time graph, not displacement time graph, because displacement time graph is giving us one type of information and velocity time graph is giving us another type of information. So we have to keep that in mind while solving the question. Now what the question is saying, the diagram below shows the velocity time graph for four parts, that is A, B, C, and there is D as well, and that is here on the horizontal axis. This is D. And they are saying that describe the motion of these four particles. For A, we are writing motion for A, that is constant, that is zero acceleration. That is zero acceleration. Constant acceleration, I should say. Zero acceleration and constant uh, velocity. Constant and zero acceleration is the answer for A. For B, you can see that velocity is increasing. So acceleration is also increasing. Uh, it means slowly accelerating, not abruptly. Slowly accelerating, not abruptly. The third part is showing us uniform acceleration. For C, we are having uniform acceleration. Yes, it is uniform. We studied that. And for part D, the body is at rest. The body is at rest because we studied that it is with the zero time. The time is passing, but there is no change in the velocity. So it means that the body is at rest. Ladies and gentlemen, there is question number, this was question number 2, not 3. Question number 2. We are going to do question number 4. Okay, ladies and gentlemen, let us first understand the question. A locomotive pulling a train out from one station travels along a straight horizontal track towards another station. The graph below shows how the velocity of the train varies with the time over the whole journey. They given us on next page number 34, using the graph determine number A part, the acceleration of the train in first 2 seconds of the journey. This is the first part, and they are saying to find the acceleration of the train in the first 2 seconds. So because this is the time, so this is t. In this a part, it is given that t is equal to 2 seconds and the velocity is what? The velocity is 40 meter per second, and we have to find the acceleration. So acceleration is a is equal to delta v divided by delta t. Yes, because it is starting from 0, so 40 minus 0 is the change, and it is also starting from 0 and 2 is the final. So from final, if we are subtracting initial, then it will be 2. So 40 divided by 2, which is equal to 20 meter per second square, is the answer for part number A. Part number B is saying that the maximum velocity attained by the train, and you can see that this is the maximum velocity till 40, then it is constant. So 40 meter per second is the maximum velocity attained by the uh, locomotive train. Okay, the C part is saying the total distance between two stations. The total distance, the time, sorry. C part is saying the time during which the train is retarding. So you can see that the train is retarding from 12 to 16. From here it is starting, which is 12, and it is going down. So it means the C part answer is from 12 seconds to 16 seconds the train is retarding. And D part is saying that the average velocity of the total distance between two stations. The total distance between two stations. I did this question to you in the previous lecture, and that is exactly the same. The answer is also the same. But let us to refresh your memory. If you want to get further detail, go back to my lecture number 8, in which we did at the beginning this question, and exactly the same data was there. Area of trapezium is equal to 1 over 2 into height into sum of parallel lines into some of the parallel lines. So I am writing 1 over 2 into 40 into, what is this distance? 2, and that is 12. 12 minus 2, 10. Plus from 0 till 16. So it is 0 till 16. 2 ones are 2, 2 20s are. And then 20 multiplied by 26, which is equal to 520 meter square. So we will write 520 meter. Ladies and gentlemen, average velocity of the train is the E part. So the total distance covered by, I am writing it here, E part, and that is the average velocity. Average velocity is equal to total displacements, and we found that divide by total time. So we also have these two datas. We found 520 and the total time from 0 to 16, and that is meter per second. So when we divide 520 divide by 16, then we are getting 32.5. 32.5 meter per second is the average velocity. Ladies and gentlemen, that's it for today. Tomorrow we will come with new ideas. We will increase our knowledge, utilize our knowledge, will use our knowledge about the speed, velocity, and acceleration, and we'll do question number 4. So don't miss the fun. For that, you have to subscribe my channel and press the bell icon so you will be informed that the new video has been uploaded. Thank you very much for watching. Allah Hafiz.